This video is on descriptive statistics and it's aimed at A-level psychology students, although it's probably applicable for anyone wanting to know about measures of central tendency and measures of dispersion. So descriptive statistics are used because they describe the dataset created by an investigation. So in psychology we might investigate in many ways, and one of the ways we do that is through an experiment. So we'd do our experiment and we'd end up with a set of data from doing the experiment. And descriptive statistics attempt to show you the central position and how spread out the data are within a set of data that you've created. So measures of central tendency are a single value that attempts to identify the central point within that set of data, and measures of dispersion show you the spread of scores in a data set. So the first thing we're going to look at are measures of central tendency. There are three measures of central tendency, and you can remember them by saying measures of central tendency. And the m stands for mean, median, and mode. And in the exam, you need to be able to identify them, calculate them, identify the advantages and disadvantages of each, and interpret them. So I'm going to give you a stimulus material so that we can create a fictional set of data, and then we can practice doing all those things. So the stimulus material, it's going to be an experiment, and a researcher believes that using a mobile phone when driving affects concentration. She has access to a driving simulator. The IV is using a mobile phone in a driving simulator or not using a mobile phone in a driving simulator, and the DV are the number of driving errors. So our directional hypothesis, which is our prediction, is that participants using a mobile phone in a driving simulator will make more driving errors than participants not using a mobile phone in a driving simulator. And the researcher would complete the experiment. In this case, she's decided to use a repeated measures design. So that means that all of the participants take part in both conditions of the IV. And once the experiment has been done, so all the participants have been in the driving simulator with a mobile phone and without a mobile phone, and all the number of driving errors have been calculated, then you create the data set. So if you look at this table, you can see the grey column shows you the number of participants, so that's our number of scores. The green column shows you the number of errors made while the participants had a mobile phone, and the blue column shows you the number of errors made without a mobile phone. So when you look at that table of data, it's quite confusing. You can't immediately see what the central score was or how spread out the data was, and so that's why we do this the descriptive statistics. We want to be able to interpret all of that data in a much more in a simpler way. So the mean is the statistical average, and you calculate it by adding up all the scores in the data set and dividing by the number of scores you have. So the green column, number of errors made with a mobile phone, is, you can see there, you add those up, so 12, add 7, add 4, add 7, add 8, add 9, add 5, add 10, add 14, add 7 equals 83. And then you divide 83 by the number of scores, and in this case it's the number of participants, so it's divided by 10. 83 divided by 10 equals 8.3. So the mean number of driving errors for participants who are using a mobile phone is 8.3. That's our kind of central point for the number of errors made in that condition of the IV. In the exam, you must show you're working out. Now, you might think it's quite simple, and you might even be able to do that in your head, and that's fine, but the examiners want to see you do that addition and that division to show the correct answer. Then you do the same with the second condition of the IV, so number of errors without a mobile phone, so 3 add 2, add 1, add 6, etc. equals 52. 52 divided by 10 equals 5.2. So the mean number of errors made while not using a mobile phone is 5.2. The next measure of central tendency is the median, and the median is the midpoint of the data set, and you calculate it by putting the scores in numerical order and then counting in from both ends to find the midpoint. So I've put both conditions of the IV in numerical order, so you start from the smallest number and then you look through the data and put them in the correct order numerically. So you can see I've done that for both conditions of the IV there, so 5, 5, 7, 7, 7, 8, 9, 10, 12, 14 for the number of errors with a mobile phone. Once you've got your scores in numerical order, you then count in from both ends to find the midpoint. So if you look at these arrows, you can see that I've counted in from both ends, and the midpoint, because we've got 10 scores, we had 10 participants, the midpoint is actually between 7 and 8. So if you had an odd number, then you would have a midpoint that is obvious, but if you have an even number of scores, then you have to work out the average of 7 and 8. So 7 add 8 equals 15, 15 divided by 2 equals 7.5. So the median number of errors made while using a mobile phone is 7.5. Then I've done the same for that second condition of the IV and found the midpoint is between 5 and 6, so 5 add 6 equals 11, 11 divided by 2 equals 5.5. So the median number of errors made while not using a mobile phone is 5.5. The next measure of central tendency is the mode. Mode means fashionable in French, and so we're looking for the most fashionable score in that data set, or you might say the most frequent score. So you just look through the data set and identify which score is the most common. So the mode number of errors using a mobile phone is 7, and the mode number of driving errors not using a mobile phone is 6. And those are our measures of central tendency for both conditions of the IV. You can see for using a mobile phone and not using a mobile phone, and you'll notice that they are different. So for the first one, drivers using a mobile phone, the mean is 8.3, the median is 7.5, and the mode is 7. And all of those, they're quite similar, and they show us hopefully the central point within that data set, but we can see that they are different. So the mean, median and mode will give you different scores, but that's okay as long as you choose one in the exam. If they ask you to calculate the mean, make sure you just identify how you do that and do that correctly. Strengths and weaknesses of the mean. A strength is that it's the most sensitive measure of central tendency as it takes account of all scores. And if they ask you for an advantage of the mean, it's fine to simply write that. The way I remember it is, if someone's being mean to you, then you might feel quite sensitive. And so that leads me to remember that it's the most sensitive measure of central tendency. It takes into account all scores. A disadvantage of the mean is that it can be distorted by extreme scores, and in such cases becomes unrepresentative of all scores. So for example, supposing your data set was 1, 2, 4, 6, 3, 4, 2, 8, 2, 46. The mean, when you add up those numbers and divide by the number of scores, is 13.2, and we can see that 13.2 doesn't represent any of those scores. The 46 is what we call an outlier. It's an extreme score, and it has distorted the mean so that the mean doesn't actually show you the central point. It doesn't really represent the majority of scores for anybody. A strength of the median is that it's unaffected by extreme scores, those outliers in the data set. So if we take that same set of data, 1, 2, 4, 6, 3, 4, 2, 8, 2, 46, the median comes out as 3.5 because you've put it in numerical order and found the midpoint. And 3.5 does represent the midpoint of most of the data. So the median can deal with those outliers because it just gets rid of them. However, a disadvantage is that it does not take account of most scores, so it can be misleading. So if you had a data set that was 1, 1, 1, 2, 2, 8, 20, 20, 21, 23, 23, the median, the midpoint is 8, but we can see that most scores are either 1 or 2 or 20, 21, 23. And so 8 is not representative of the most typical central point in that data set. The strength of the mode is that it's unaffected by extreme scores, those outliers in a data set, and it's useful when the data are in categories. However, a disadvantage is that it tells us nothing about the other scores and the range of scores, and so it's an unrepresentative measure. And also, there could be more than one mode, and that's the one that I remember most and that I would use in the exam. If they ask you for one limitation of the mode, you could just say there could be more than one mode. The next descriptive statistic that we're going to look at are measures of dispersion. So measures of dispersion show us how spread out the scores are within a data set. And if you look at that picture there of the dandelion clock, if you blew really hard on that dandelion clock, then those feathery fronds are going to be widely dispersed. They're going to go all over the place. Whereas if you only blew on it very softly, then all the feathery fronds will land in a very similar place, probably very close to the actual dandelion clock. And that's a good analogy for measures of dispersion. If your data set, if all the scores are like spread out all over the place, that's as if it's a really windy day or you've blown hard on the dandelion clock. All the scores, all those feathery frogs, they're going to be spread out wildly all over the place. Whereas if you only blow very gently on the dandelion clock, then all the scores, those feathery frogs, will be roughly in the same place and very close to the original, and what we would call the mean. So we're going to have a look at that. So there are two measures of dispersion that you need to know, the range and the standard deviation. You need to know how to calculate the range, but you don't need to know how to calculate the standard deviation. So the range is the arithmetic distance between the top and bottom values in the data set, and then we usually add 1. So in our data set for number of errors with a mobile phone, the highest value is 14, so that 14 was the most amount of errors somebody made, and the lowest value is 4, so that was the least amount of errors. So we take the lowest value from the highest and add 1 to get the range of scores in the data set. In the exam, you must show you're working out, so you would show 14 minus 4 equals 10, 10 plus 1 equals 11. So the range for the number of driving errors made while using a mobile phone is 11. The range for the number of driving errors made not using a mobile phone is 13 minus 1 equals 12, 12 plus 1 equals 13. For AQA A-level psychology, they will also accept the lowest value taken from the highest without adding 1. And that's what I learned when I learned about doing the range way back in primary school. And that's what I would do in the exam. I go for the easiest option. So 13 minus 1 equals 12, and you would say that the range for the number of errors made not using a mobile phone is 12. The range shows us, so for our experiment we can see here, the range shows us that the participants who were not using a mobile phone had a greater variety of scores than the ones who did. Their scores were more dispersed because 13 is higher than 11. And so that's the kind of language that you want to say. If you're talking about a measure of dispersion, you're talking about one set of scores having a greater variety or having a greater spread of scores. A strength of the range is that it's easy to calculate and takes account of all values. A disadvantage is that it's not appropriate to use when there are extreme scores or outliers, as these can give a distorted picture. So if you look at this data set, 1, 2, 1, 1, 2, 3, 1, 2, 3, 46. 46 is the outlier. So 46 minus 1 equals 45, and that tells us that the range of scores in the data set is 45. And that's really huge, when really, when you actually look at the data set, most people got 1, 2 or 3. That was their score. And so it can be misleading if you have an outlier. The next measure of dispersion is the standard deviation, and this is a more sensitive measure of dispersion of scores around a mean. It tells us how the data is spread out around the mean. In order to use the standard deviation, the data must have a normal distribution, which is shown in a bell-shaped curve. So this is our normal distribution shown in a bell-shaped curve, and you can see the red line on the picture shows the mean, and when you have a normal distribution, the mean, median and mode are all exactly at the centre point. So the standard deviation shows us how closely clustered the scores are around the mean, and the blue dotted line represents the standard deviation, and we can see one standard deviation away from the mean, and so that's showing us the spread of scores around the mean. What does a large standard deviation suggest about the data set for one condition of the IV? If you look at this picture, you can see a large standard deviation, and so if you actually look at it, you can see that one standard deviation from the mean, all the data is very spread out. That shows us that the scores will be widely dispersed, or that they will vary a lot. So if you have a large standard deviation, this shows us that the scores are not closely clustered around the mean. And the opposite is true for a small standard deviation, as you can see here. If you have a small standard deviation, this shows that the scores are closely clustered around the mean. So the mean is the central point, and if you have a small standard deviation, most people got a score very close to the mean. The standard deviation for our experiment, so this table shows you the mean and standard deviation for both conditions of the IV. And the standard deviation for the number of errors made using a mobile phone is slightly lower, 1.2, than for not using a mobile phone, 1.6. In the exam, if it asks you to interpret a table and the standard deviations are similar, say that. Identify that they're similar, but one is slightly higher or slightly lower than the other. and then go on to say what that means. So it shows that although those using a mobile phone made more errors on average, 8.3, than participants without a mobile phone, 5.5, their results were more consistent. So participants made a similar number of errors while using a mobile phone compared to those not using one. A strength of the standard deviation is that it takes account of all scores and gives a very accurate measure of the spread of the scores, but a disadvantage is it might hide some of the characteristics of the data set, especially if you have outliers or extreme values. So, in the exam you might be asked to interpret a table of descriptive statistics. So I showed you a table with the mean and the standard deviation. This table shows you the median and the range. So pause the video, see if you can answer this exam style question within 5 minutes. It says, what does this table tell us about the driving errors of the two groups? 4 marks. So you want one paragraph about the median, one paragraph about the range, and make sure you actually incorporate the data from the table into your answer. The reason you get 5 minutes is because in the exam you get about 1 minute per point, 1 mark, and plus a little bit. So see if you can write it in 5 minutes. So the answer is, the table shows that driving with a mobile phone will cause more driving errors because the median number of errors with the mobile phone, median 7.5, was higher than the number of errors without a mobile phone, median equals 5.5. The range tells us that the scores for the drivers without a mobile phone were more dispersed than the ones who used a mobile phone. So there was a greater variety of scores for participants who did not use a mobile phone because 13 is higher than 11. See if you can interpret this table of data. It's a table to show the differences in scores on a spelling test between girls and boys and shows the mean and standard deviation. So again, pause the video and answer the exam style question. What does this table tell us about the spelling abilities of the two sexes? 4 marks. And the answer is, the table shows that females were, on average, better at spelling than males. They had a mean score of 16, which was higher than the males of 12. The females' score were more varied, as their standard deviation was 5.6 compared to the males, which was 3.4. So although the boys were not as good at spelling, they were more consistent in their scores. So what you're going to do now is test your knowledge, and the stimulus is related to the concentric star experiment. So if you're a psychology student, you'll know all about Henry Molaison, who was a young man who had an accident as a child which gave him severe epilepsy. And so the epilepsy was ruining his life, so they did some surgery and they removed a part of his brain called the hippocampus, not really knowing what it did. And they found that it did cure his epilepsy. However, it meant that Henry Molaison could no longer form any new long-term memories. So he couldn't lay down in memory anything new from that point in time. And at first they thought that it had destroyed his entire long-term memory, but then they realised that it had actually only destroyed his episodic and semantic memories. And they did an experiment to test his procedural memory. So the experiment they did was with concentric stars. So if you look at those 2 stars on the picture, those are concentric stars, 1 star is in the other. And Henry Molaison was asked to draw between the lines of the star, but only using his reflection in a mirror. So he couldn't see his hand drawing between the lines, he could only look at his hand in a mirror. And that's actually a really tricky thing to do. You can try it yourself and see. So the first time he did it, he was really bad at it and he went outside the lines loads. But the more he did it, the better he got, showing that he was building up new procedural memories because it was a skill. But he couldn't remember actually doing the task, so he got better at it without remembering, and that's because he had no episodic or semantic memories. Episodic meaning the episodes in his life, the things, so what he did last week or last year, he couldn't remember those. So he couldn't remember doing it, but he got better. So the stimulus is related to this concentric star experiment. So I'll read you the stimulus, and then the questions are on the next couple of slides. The PowerPoint and the handouts of these questions are available. You can click on the link in the description below, or if you're my students, I'll have given them to you or download them off Moodle. So the stimulus material. Following research carried out on Henry Molaison, some psychology students decided to test procedural memory using the same concentric star experiment. They recruited 11 participants by tweeting information about the experiment on Twitter and requesting people to contact them if they wanted to take part. The participants were required to draw between the concentric stars by only looking at their reflection in a mirror. The number of times each participant drew outside the lines was recorded. They then practiced the task for 20 minutes without their scores being recorded. After this, they were given a 5-minute break. They then completed the task a final time, and again the number of score times they drew outside the lines was recorded. So this is the data set that was created. You can see there were 11 participants, and the green column shows the number of times they drew outside the lines before practice, and the blue column shows the number of times they drew outside the lines after practice, after 20 minutes practice. And so that is your data set. There's a lot of research methodology practice questions to use with that stimulus and that data set, including calculating the mean, median and mode. So if you're Y students, you need to complete all of the questions, and if you're up to question 16, and if you're year 2, you get some extra questions, lucky things. So year 2, you also have to complete questions 17 and 18. So question 17 on inferential stats, and question 18 is design a study for 12 marks. The only other thing to say is that the specification for descriptive statistics includes measures of central tendency, measures of dispersion. It also includes calculation of percentages and positive, negative and zero correlations. So this video hasn't covered calculation of percentages or the correlations, so make sure that you revise that, and I might get on the case to make another video.
As I look into those eyes, I see those lies you keep from me. Now I realize those truths you hide, yet still it's never forgotten what you mean to me. Can I hold on now? Just wait and see.